Alright, so we're going to go over the graphic organizer and how to use the different trig equations to find sides and angles. And you can see we can always use Pythagorean theorem, right? And Pythagorean theorem is defined as a squared plus b squared equals c squared. And Pythagorean theorem is only useful when you have two sides of a triangle and you're trying to find the third. The rest of the time, Pythagorean theorem isn't helpful, and that's where we're going to have to use trigonometry. So here on the graphic organizer, the first side of it is finding a missing side. And generally, we round these to the nearest tenth. And I'm not a huge stickler about that, but you're going to see on all the solutions, all those answer keys, I'm rounding to the nearest tenth. So the first one is the tangent equation. We know it's tangent because we have the side opposite of the angle. Here's the opposite side. And we are trying to find the adjacent side. Adjacent just means it's next to the angle. The other side next to the angle is a hypotenuse, right? And that has its own special name. So with tangent, we're going to go ahead and set up this equation. Now, I like to set it up as over 1 because I like to use cross multiplication. There's a lot of ways to solve an equation. I'm just going to model that way. All right, so my first step is to set up the tangent equation. Tangent of 60 degrees. I like to put it over 1 equals opposite over adjacent. And there we go. Now it's just like a normal proportion problem, which means we have a fraction equals to a fraction. So we're going to have to cross multiply. Let me highlight where we're multiplying, right? We're taking x times tangent of 60 and 15 times 1. So x times tangent of 60 equals 15 times 1. And I just wrote that as 15 because 1 times 15 is 15. Now we have to get x by itself, so we're going to have to undo multiplying by tangent of 60 and divide by tangent of 60. Tangent of 60 divided by tangent of 60 becomes 1, so we're left with a 1x on that side. And on the other side, we're taking 15 divided by tangent of 60. I realize tangent of 60 looks weird, but remember it's just a number. So I'm going to go over to my calculator and just type in tangent of 60. And that seems weird. Oh, yes, it's my mode. So you'll have to make sure you're careful with the mode on your calculator. If you need to change it, go to mode, go down. Make sure, click enter on degree, and then you can either hit clear or second mode to quit out. Now when I type in tangent of 60, I get 1.7. So really all we're doing is taking 15 divided by 1.7. So I'm going to go ahead and do that right now. 15 divided by tangent of 60. And I get 8.66. I'm going to round that to about 8.7. If we want to verify, is it reasonable to think that this side would be less than this side? I think so, because the larger angle should go with the larger side. And that side that's 15 has a 60-degree angle, which means the side that has this 8.7 has a 30-degree angle. Remember, these angles add to 90, and all three add to 180. So, all right, next one is with sine. Again, I like to use cross multiplying, so I'm going to put my sine of theta over 1. So here we go. And all this theta symbol means is angle. So I'm going to go ahead and say sine of 38, my angle, over 1 equals sine is opposite over hypotenuse. So x over 14. Next step, cross multiplication. I'm going to take 1 times x and 14 times sine of 38. And you can always type that in as sine of 38 times 14. Just remember when you type in an angle on your calculator, it automatically puts a parenthesis here. So if you're taking sine of 38 times 14, make sure you have to close that parenthesis. So your calculator knows where the angle is. Otherwise, if there's a number after it, it's going to take the 14 times 38. I'll go ahead and show you that quick example. 14 times sine of 38. Better make sure that was the right numbers there. Yep, that was it. So it's about 8.6. If we go the other way, sine of 38 times 14, you'll see we get kind of a weird answer, and that's because we forgot to close our parenthesis after the 38-degree angle. So what it was actually doing was taking the sine of whatever 38 times 14 was. So we have to let it know when the angle ends, and again we get about 8.6. And again, my hypotenuse is 14, which is the largest size, so I think it's reasonable to say that this side has to be smaller. Our last one's cosine, same idea. Put it over 1. Cosine of our angle equals adjacent side over the hypotenuse. So I'm going to take 6 over x. Again, I'm just going to cross multiply. X times cosine of 83 equals 1 times 6. I got to get x by itself, so I'm going to divide both sides by the cosine of 83. And that's it. All I have to do is type that in my calculator to get my solution. Let's see here. 6 divided by cosine of 83. There's nothing after the 83, so that's why you can go ahead and click enter. If you'd like to just get in the habit of closing that parenthesis after the angle, you can always do that. And let's see, our side length is 6. Is it reasonable to think the hypotenuse is larger? Yes, I think that makes sense. So I'm going to call that about 49.2. There we go. That's how you use the trig equations to find side lengths. On the other side of the handout, where you can see that we can find angle measures, and that's what's given here is the angle measure. On this first one, I'm going to set it up as if we were finding the side, and then I can show you how you can actually use the second equation here to find the angle measure. So if we were going to find the side length, we would say tangent of our angle measure equals opposite over adjacent. Now this symbol here is theta, and all theta represents, it's a Greek letter that represents an unknown angle measure. So we're trying to find this unknown angle measure. On the case where we're finding side lengths, we can see the unknown is in the fraction, which is why we had to cross multiply. Here it's by itself. So all we have to do is get rid of this tangent. And to get rid of tangent, we're going to use the inverse of tangent. And you can see I did that to both sides, because if I do it to one side, I have to do it to the other. So inverse of tangent undoes tangent. We're left with theta on that side. And on this side, I just have to type that in my calculator. So on the calculator on mine, it's in blue. So I'm going to hit the blue button first, then inverse tangent. And 3/4. And there you go. You can see it's about, I'm going to call it 37 degrees. Traditionally, we round angles to the nearest whole degree, so that's where I'm going to call it there. I'm definitely okay with you calling it 36.9 though. There we go. Now on the next one, I'm just going to jump straight to this second equation, because this second equation is how we find angle measures. The angle equals the inverse sine ratio of the opposite over hypotenuse. So in this case, we do have the opposite. We have the hypotenuse, so I know theta is equal to the inverse sine of opposite over hypotenuse. Just going to my calculator, typing that in. So it's about 21 degrees. And remember, all this is just a ratio in your calculator. Your calculator has all the ratios put in it. For example, if I was doing the same problem, but let's say this was a 4 and an 11, we should get the same angle. It's just a triangle that's half the size. So let's go ahead and check. Inverse sine of 4 over 11, and I should see that it's also 21 degrees. So these ratios are just saved in your calculators, and you're just using the calculator to figure out which ratio it is for you. Last one is our cosine. Largest side's hypotenuse, adjacent side, there's no opposite, so theta equals the inverse cosine of 10 over 11. Again, just second cosine. I'm going to call that 25 degrees. And there you go. That's how you can use the Trig equations to find sides or angle measures. You can see with sine, cosine, and tangent, there are three pieces. A side, an angle. A side, an angle. A side, an angle. So that's why Trig's useful. You either have an angle and a side and you're trying to find a second side, or you have two sides and you're using that to find an angle. It's the only thing Pythagorean theorem can't do, right? Pythagorean theorem is great for using two sides to find the third side. It cannot find angles for you. So hopefully that was helpful. Let me know if you got questions.